Hi everyone, in this video we'll do some examples of one-sided limits. Let's go! Here's f of x. I want to analyze this function with every limit we know. Pause the video and try these out, then I'll show you my approach. Well, as x approaches 1 from the left, y approaches 1. As x approaches 1 from the right, y approaches 0. Seeing that the two one-sided limits aren't equal, we conclude that the regular limit does not exist. Easy peasy. Now we have g of x. Let's once again try every limit on this function. Go ahead and try it yourself, then come back to see the Raoul's Math World way. As x approaches 2 from both the left and the right side, y approaches 3. That means both our one-sided limits are equal to 3. Because they're equal, our regular limit exists and is equal to 3. Nice and easy. Here's the function h of x equals 2 times the absolute value of x over x plus 1. Quite a mouthful. Let's throw all our limit tools at this graph. Pause, try, and return. As you can see, when x approaches 0 from the left, y approaches -1. As x approaches 0 from the right, y approaches 3. Since our one-sided limits aren't equal, the regular limit does not exist. Once again, an easy problem. Now let's say that we aren't given a graph, but we are told that the left-hand limit of f of x as x approaches 6 is 4, and the right-hand limit of f of x as x approaches 6 is also 4. What can we say about the limit of f of x as x approaches 6? Try that one out by yourself. Well, we know that the limit exists if and only if the two one-sided limits are equal, and the limit value should just be the value of the one-sided limits. Since both one-sided limits are equal to 4, we can say that our limit should also equal 4. Nice. Okay, similar problem, but this time we're told that the left-hand limit of g of x as x approaches 8 is 2, and the right-hand limit of g of x as x approaches 8 is 5. What would the limit of g of x as x approaches 8 be? Try it out. Well, if you pay close attention, you see that the one-sided limits are not equal. That means that our regular limit does not exist. Very simple, no? Alright, last problem. Given that the limit of h of x as x approaches 3 equals 0, what are the one-sided limits equal to? I'll give you one last opportunity to work it out yourself. This problem is really asking the reverse of the logical statement that we've used in the last two problems. We know that if the regular limit is equal to a value, then both one-sided limits must also equal that value. Thus, our one-sided limits are equal to 0. Good math sesh, everybody. I hope you derived something useful.